All right, so for those of you guys who are new, we are going to just go through some free response questions from the old AP Calculus exams. Again, these guys are going to be real similar to what you guys are going to see. They're not going to be the exact same questions, but they're going to be of similar threads, similar difficulty. All right, and I'm going to do my best to explain like what and why everything, is happening here. And if you do have questions, you can please feel free to ask them. All right, you can make use of the chat box, which is right here. Some of you already see it. And if you have a question that is, really complicated and you don't want to type it all out, you can please feel free to unmute your microphone, but please warn me in the chat box first, okay? All right, can everybody just say yes, no in the chat box, and then we will get going. Awesome. All right, so this is the 2017 free response, and I'm going to do my best to explain all of the concepts around them. All right, so here we have a tank that has a height of 10 feet, an area of the horizontal cross section is over here. And so essentially we have this table. It's looking like it's going to be a Riemann sum thing here. The function a is continuous. All right, that's important. Why is that important? It means that a lot of the theorems that we learned in the first semester of calculus are going to hold true. It means that the function isn't going to behave weirdly. All right, and a lot of the assumptions that we have are going to hold true. All right, and so it decreases as h increases, and then we have this table. All right, so for part A, let's use a left Riemann sum with 3 subintervals to approximate the volume of the tank. All right, so our volume, so let's start with part A. All right, our volume is going to be the integral from 0 to 10 of your area, and then times the change in the height, all right? And so we can think of this as basically taking the area times the height and then adding it all up. Makes sense. All right, they want us to split this with 3 subintervals, and we can only use the ones in the table that are provided, okay? And they want us to use the left endpoint. Does everybody understand what I mean by the left endpoint? Okay, great. So so let's go ahead and just break it up. So our first subinterval is going to be area of 0. All right. So this is the left endpoint, right? A of 0. And then the width of this interval is going to be 2 minus 0. All right. So this is my width, if you will. All right. Oh, I guess I should just call it the height, shouldn't I? Okay, so height. All right, and then I'm going to add area of 2. So right there. And then the width of the height of that interval is going to be 5 minus 2. All right, this minus that. All right, and then I'm going to add one more, area at 5 times the width, which would be 10 minus 5. All right, and then we will just plug and chug, add them all up. And let's see. So this is 50.3 times 2 plus 14.4 times 3 plus 6.5 times 5. And if I add that all up, I get 176.3 feet cubed. Okay. All right. Does anybody have any questions on that? So I want to take a second. This was the left-hand Riemann sum. I want to take a second and actually calculate the right-hand Riemann sum. I know they didn't ask for it, but can't hurt to practice. So the only thing I would change here is that I would start my calculation over on the right. All right, and so essentially I would be taking the right side of each endpoint. All right, so I'd be taking that, which is a of 2 times 2 minus 0, all right, plus this one, a of 5 times 5 minus 2, plus a of 10 times 10 minus 5. I'm not going to plug and check, but I wanted to actually write that out for you guys. All right, does everybody see the difference? Awesome. Great. Okay, so does the approximation in part A overestimate or underestimate the volume of the tank? Okay, so what do we think? So this I don't need anymore. What do I think? So if you're not sure, you can always try and draw it out, right? So let me go ahead and just draw a function that kind of looks like it might be decreasing. All right, and then let's figure out what our Riemann sum might look like. All right, never hurts to draw a picture. All right, so let's say that that is a of 0. I would go up, and so I'd go up to here and then over, and that might be my rectangle that I just drew. All right, and then let's see, maybe this is 0.2. I go up and then I go over and down. All right, and maybe that's 5, and I go up and over. All right, and I'm going to notice here that I have this little area that I'm accounting for in my sum that is not under the area of the curve, right? So therefore, this is an overestimate because I have extra area. Does that make sense to everyone? All right, so when in doubt, draw a picture if you need help with that. All right, does anybody have any questions? What would my answer be if I had used the right Riemann sum? Please. So the question is, would a graph be a sufficient explanation by itself? I don't actually know. I think that you have to say that it's an overestimate because A is decreasing. And it's a left Riemann sum. But a graph is definitely a good way to look at it. So maybe. Let's look at the right-hand Riemann. If they ask, I'm going to actually go through that. That's a great question. You killed my punchline. The question is, if they asked if the right Riemann sum was used instead, what would would it be an overestimate or underestimate? Great question. You stole it from me. All good. All right, so let's go through. If I did the right Riemann sum, I would go to 2. It's okay. All right, I would go up to 2 and I'd go over and I would have, that would be my rectangle, right? And then I go to 5 and I would go over and I go up to 10 and then I go over. And what we're going to see here is that I have the red area is area that is unaccounted for. So the right Riemann sum would be an underestimate. Does that answer your question? Don't worry if you guys are taking notes frantically. Don't fret. We will be making a recording available to you somehow. All right, that's a little black box to me, but I know it's happening. Okay, for the area, All right, the area in square feet of the horizontal cross section is this thing. All right, we want to find the volume of the tank. All right, this is a calculator problem, so you get to use your calculator. All right, all we have to do is set it up properly and get a right answer. All right, so integral from 0 to 10 of 50.3 over e to the 0.2h plus h. All right, and then don't forget when you're setting it up to add the dh. I tend to forget that. All right, does everybody know how to do this on the calculator, or do we need a review? Totally happy to do that. We need to see that? All right, hopefully everybody has a TI 83 or 84 or something very similar. All right, you want to make sure that you are in function mode. All right, and then what you have to do is put this function into your y equals. All right, so if you hit the topmost button that says y equals, all right, put in that function 50.3 divided by e. I'm assuming everybody has like the correct calculator. Yes? Yes, no? Great. Okay, so I've got my function in there, and I just hit zoom 6 so that I can see what I'm looking at. All right, it looks like I have something of, looks like an asymptote to me. It's kind of ugly. All right. Make sure I put the function in right. E to the 0.2 x plus x. Yeah, okay. Alrighty then. Alright, so then in order to calculate the integral, you hit second and then trace, say second, and then trace, which has the word calc, and then you go down to 7, which has the symbol that looks like this, which is the integral sign. Lower limit is 0, and upper limit, we want to put in 10. All right, and then it's gonna shade it in for us, and we got 101.325, and then you want to make sure you write in feet cubed. All right, so you are not expected to do that. If we're trying to find volume, why are we integrating the area? So, okay, the area here. So what is a volume? So if I just have the volume, let's say of a cube, or a or let's say I have a, forgive my art skills, I was not very good at art in high school or college. All right. So this is area, and then you're adding up the area up to the height. Right, so we're going from height of 0 to h. This isn't going to be tested, so that's actually not true. All right, you should be, now they set up the integral for you. All right, so you should be able to do this one at least. All right, and then regardless, if they just gave you a function and then maybe called it length and width, you would be finding area. You would do it by the same method. So I think it's actually useful to go over. Otherwise, we wouldn't go over it. Okay, does that make sense? So you're taking the area, and then you're taking the area of a bunch of slices, adding them up to over the height to get the volume. Okay. Any other questions? All right, great. So, do we need to find the answer to the third decimal place? I would say that 2 to 3 is good. I mean, the answer key has more than that. All right, but I would say that 2 to 3 is probably fine unless they specify. Okay, water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 foot, should be feet per second, foot per minute. Using the model, find the rate at which the volume is changing with respect to time. Okay, so when we see the word rate, what do we think of? So rate equals derivative, right? So if the rate is a derivative, we've got to take the derivative of our function, right? And our function then is the integral of 0 to h of f of x dx. Everybody with me? So then I want to take the derivative of this. So by the fundamental theorem of calculus, what's the fundamental theorem of calculus? It's my favorite theorem. If I take the derivative of the integral, then I get the function back. All right, so if I take the derivative of this thing, then I just get f of h times, now I have to remember to use the chain rule, dh dt. Everybody with me? So if I take the derivative of this thing, you've got to take the derivative of the integral, you get the function back, but then you have to take the derivative of the bounds as well, so that's dh dt. All right, so this boils down to f of 5, and then they gave you dh dt, right? So 0.26 feet per minute. All right, and then we would plug 5 into here and get a number. Is everybody with me? Yes, no? Yeah? Okay. All right, so let's see. Let's get a number. 50.3 divided by e to the 0.2 times 5 plus 5. All right, so let's see. All right, I got something that looks like 1.69. Okay, so the function. So this is essentially the chain rule. So I'll just kind of slow down a little bit. So here's my function. So the volume here is the integral from 0 to h of f of x dx. All right, and I want to take the derivative of this. I want to take the derivative over time. All right, when I take the derivative, it cancels the integral. So I just get f of h. All right, but since I'm taking the derivative with respect to time, I have to correct for that by multiplying by dh dt because the bound is a variable. All right, so it's essentially the chain rule. Kind of like when you learned implicit differentiation. Does that make sense? No problem. All right, so that's question 1. Move on to question 2. All right, any questions on question 1? All right, great. Okay, so when a certain grocery store opens, it has 50 pounds of bananas on a display table. Cool. And then we're removing them by this function. And then we're adding them to this function. Okay, so for the first question, how many pounds of bananas are removed from the display table during the first 2 hours? All right, so what do I want to do with this? So the function, what we want to integrate it because I'm adding them. So 0 to 2 and then f of t dt. All right, everybody okay with that? All right, and then we would use the calculator to go ahead and find that. Does anybody, I think everybody knows how to do that. All right, so when we do that, we get 20.05 pounds of bananas. So I'd probably round that to 20. All right, and then we want to find f prime of 7. So now that's more interesting. All right, I'm going to minimize this a little bit, and I'm going to minimize it so that I have a little room to work. So let's go ahead and take the derivative of this thing. So f of t is 10 plus, I use the calculator. So in the same way, you would not be expected to integrate that by yourself. It's a pretty complicated function. You will be expected to differentiate by yourself, though. All right, so let's go ahead and find the derivative of this. All right, so f prime of t. All right, I'm going to drop out that 10 because it's a constant. Derivative of a constant is 0. All right, and then I'm going to have to use the product rule and the chain rule. All right, so product rule is first, derivative of the second, derivative of sine is cosine. So we have cosine of the argument, all right? And then I've got to take the derivative of the inside. And for right now, I'm just going to leave it as derivative of 1/100th t cubed. I'll come back to that, all right? Plus, so this is the first part by the product rule, all right? And now we have to do the second part. So plus sine of 1/100 t cubed, and then derivative of the first. All right, now I'm going to go back and actually take the derivatives. All right, this thing becomes 3/100 t squared, and then the derivative of this thing is 0.8. Everybody okay? So then all together, f prime of t is 0.8t. Cosine of 1/100 t cubed times 3/100 t squared plus sine of 1/100 t cubed times 0.8. So product rule and chain rule. All right, and then if I plug in f prime of 7, all right, bear with me while I plug it in. All right, make sure you ask questions if you have them, and then don't forget to make sure that this calculator is in radian mode. All right, gonna mess you up if you're not in radian mode. I'll just work here. Okay, so I just plugged all those numbers in and I got negative 8.12. Okay, so that happens to be correct, which is good. And then we have to actually interpret the actual answer in context of the problem. All right, so the way that we would interpret that is after 7 hours of the store opening. All right, this is a derivative, so the rate, the bananas are being removed has decreased by 8.12, and then my units here would be pound per hour per hour. All right, that would be the meaning of that. All right, does anybody have any questions on that? Everybody hanging in there? I know it's a Friday night. Why pounds per hour? Per hour. All right, so the original units are pounds per hour. And then when I took the derivative, it's a rate. So I get another per hour. Make sense? No problem. All right, for C, is the number of pounds of bananas increasing or decreasing at t equals 5? All right, so this one I think is a little easier than it looks. So I would just take g of 5 and subtract f of 5 because this is the pounds that are added and then this is the pounds that are removed. All right, and if we get a positive number, that means that we should be increasing, right? And if I get a negative number, it should be decreasing. All right, so not too terrible. If we go through and, well, let's go through and figure out what g of 5 and f of 5 are. All right, so f of 5. They made this one complicated, didn't they? All right, 13.796 and g of 5. All right, g of 5 is 11.533. All right, so g of 5 minus f of 5 is less than 0. All right, so the pounds of bananas are decreasing. All right, does anybody have any questions on part C? Yes, no? Why I can, okay, so the question is, why can we just take g of 5 minus f of 5? So if this is the rate at which they're being added and then this is the rate at which they're being removed, if I subtract them, then isn't that going to give us whether I have a net positive or negative? So the answer would be yes. So differential equations that are separable are on your exam, but I would say differential equations that you would take after you take multivariable calculus are not. So only the easy ones. All right. New problem. All right. How many pounds of bananas are on the display? So this is asking for a set number. All right. And so does everybody understand that F and G are rates? Everybody with me on this? These are rates. So in order to get like a number, what do I have to do with a rate? You have to integrate a rate, right, to actually get the number. So how many pounds of bananas? All right, well, we started with 50 pounds because they tell us that. All right, and then we can add the rate at which we're taking them away. Sorry, we can add the rate at which we're adding them. So that would be this function. Everybody with me? Now note the bounds here, right? We only started adding bananas after 3 hours. All right, so I'm starting at 3 hours and I'm going till 8 hours of g of t dt. All right, so this is the amount that were added. And then I'm going to have to take away the bananas that we took away. So I'm going to subtract 0 to 8 of f of t dt. All right, so then this was the amount that were taken away. All right, and then that would be the total amount that we have left. All right, I'm not going to plug and chug that into the calculator, but that is the setup. All right, does anybody have any questions? I know the rates can be confusing, so if you have questions, ask them now. All right. So the next set of questions were deemed to be non-calculator questions, so we should be able to do them without a calculator. So I'm going to aim to do them without a calculator. However, I do believe that you guys will have access to a calculator for your entire 2-question exam. All right, so just kind of keep that in mind. Okay. I think that the calculator problems are going to be similar. I think that they encompass all of calculus, so I think that they're fair game. All right. So here we have a function that's differentiable in the closed interval. And now note here that this is f prime. All right, so be real careful with what they are asking for. All right. Okay, and then they give us that f of -2 is 7, and then we have this graph, great. So we want to find the values of f of -6 and f of 5. All right, so does everybody agree that to find f of -6, I'm going to have to take my derivative and integrate it? Yeah? Cool. All right, so here is how I would set this up. So f of -6 should be f of -2 plus the integral of -2 to -6 of my derivative. All right, and then that would give me the area that is encompassed by that derivative graph. All right, that should give me the value of the derivative. So we're using the initial value to help us out. All right, so this is 7. All right, and then I can find this area by doing, by just using geometry. All right, so 1/2, if I look at this triangle here, of, let's see, so the height looks like it's 2, and then the base is 4, so 7 plus 4. Oh, careful CM. That needs to be a minus sign. Okay. So did anybody spot my mistake? This is 4. So 7 minus, I've got to flip my bounds here. 6 to -2 because of what was actually in the area. All right, so this is -4. That's tricky. That's a little mean. Okay, any questions on that? Hit me. Quick question. So the question's probably going to be on the bounds. Since I started at -2, why do we add the -2? Because I know what it is. So I'm starting at -2, and then to get the value at -6, I add the area from -2 to 6. All right, but what they gave me on the graph is the integral from -6 to -2, so I have to flip those bounds, which makes it a minus sign. All right. Yeah, it's a little tricky. Okay. All right, so that's that. So I'm just going to write f of -6 over here. So f of -6 was 3. All right, and then let's go ahead and figure out what f of 5 is. All right, so I'm going to set this one up the same way. All right, so you got to always have to have somewhere to start, right? So f of 5 is going to be equal to f of -2 plus the integral from -2 to 5. You with me? So then this is 7 again. All right, and then I need to get from -2 up to 2. All right, so let's see. That area, so r looks like it's 2, so pi r squared, right? But it's a semicircle over 2. All right, and then it's below the axis, so it's negative. All right, so 7 minus 2 pi, and then I need to get the area of this triangle. All right, so plus 1/2, the base is 3, the height is 2. All right, so that looks like 10 minus 2 pi. Is everybody good? Yeah? Fantastic. Everybody okay with the initial condition? Okay. On what intervals is f increasing? Well, we did happen to just find a couple of them. All right, so we know that it's essentially increasing on the intervals that we just found, right? So let's go ahead and actually just say that. So f is increasing when f prime of x is greater than 0. All right, so this we can just read off the graph. All right, so we're increasing from -6 to -2, right, above the graph there. This is an open interval, all right? It's below the x-axis on -2 to 2, so that is not increasing. And then we would be increasing again, it looks like from 2 to 5. All right. And I believe we can leave these closed, right? They take the 0. All right. So for part C here, find the absolute minimum. Okay, so an absolute minimum, we have to be careful. All right, we want to know, so f prime of x is either going to be equal to 0 or it's going to be an endpoint. All right, so remember when you have a closed graph, you always have to check your endpoints. All right, and so if I look at my graph here, when is f prime of x equal to 0 on my interval? Well, it looks like -2 and +2, right? All right, and then it looks like over here it's positive, and then there it's negative, and then up here it's positive again. So it looks like this is going to be a maximum, all right, and then this guy is going to be a minimum. Does everybody agree with that? So I can include 5, but it's an endpoint, so we would want to check it anyway. But I don't have enough information to be able, so yes, it does. We would want to check the endpoint. So it is 0 there. But if anything, it would be a maximum because my derivative is increasing. Okay. All right, so at 2, I have a minimum. All right, and then how do I go about figuring out what my function is? Well, we have some values, right? We just made some. So we know at -6, we got 3. Can we justify it by saying that f prime of x goes from negative to positive? You can justify it being a minimum, yes. All right, but you can't justify it being the absolute minimum. All right, does that make sense? We actually have to go through and find the values, which I'm about to do. All right, so we figured out at -2 we were at 7 because they told us this. All right, at 2 we would be at 7 minus 2 pi. All right, does that make sense? I just added in that area. And then at 5, we figured out it was 10 minus 2 pi. All right, so which one is my absolute minimum? So your choices are here and here, right? So which one's smaller? Seven minus 2 pi is smaller than 10 minus 2 pi. All right, so you can say that f of 2 is 7 minus 2 pi. Note that they asked you for the minimum value, so you needed to give the y value, not the x value. All right, and then your justification is that the derivative is 0, and you plugged in the values and you saw that it was the absolute minimum. Make sense? Everybody okay? All right, I'm going to assume everybody's okay. Fantastic. All right, for each of f prime of -5 and 3, explain what the heck is going on there. All right, so which of these can we find? We can find one of them. Okay, so Lily asked if 2 is the only point where the function goes from negative to positive, can't we assume it's the only minimum and therefore the absolute minimum? No. So you must check the endpoints on a closed interval. All right, let's say that I have a function that, looks like, this. And then down here, it's closed. All right, so what's my absolute minimum? All right, this is a minimum, right? Right here. But this is the absolute minimum because it's closed there. So this point most certainly qualifies, but we have to check the endpoints. It's really easy to forget that. Super easy. Does that answer your question? This is like an f of x. This is just the function. But since the endpoint, this is a derivative. And it could touch and go, right? Hypothetically. It's easy enough to check. We can get the value using the integration. The moral of the story is check the endpoints. Okay, I'm going to move on. For f prime of -5, does everybody agree that the derivative of my second derivative is going to be the derivative of the derivative? So I can just take the slope of this line. So f prime of -5 is what? So just the slope, so change in y is due, and change in x is 4, so -2/4, -1/2. Everybody good with that? Slope of this? Wow, that's terrible handwriting. Okay. F double prime of 3, we have a little bit more of an issue. All right, so if I take a look at this, this is definitely not smooth, right? So if I take the limit as x approaches 3 from the left, it's going to be, well, it's positive, right? This one's positive. And then on the other side, the derivative is negative. You guys with me? Tough crowd tonight. So positive slope here, negative slope there. So therefore, f double prime of 3 does not exist. All right, because I don't have a smooth transition. Okay. Does anybody have any questions on that question? Can we say does not exist because there's a corner? That is perfectly fine. That's perfectly fine. All right. I'm going to move to question 5. because I think that particle questions happen on every AP. I have not met an AP Calc exam without a particle question. So we're going to do that one. This is a bit off topic, but when solving limit questions, can we say positive or negative infinity, or does not exist fine? So my answer to that question is that if, let me answer your question with some examples actually. So let's say that you have a function that looks like this. All right, and let's call this 2. All right, here we would say the limit as x approaches 2 does not exist. But if we had a question, or a function that looks like this, like that, then the limit as x approaches 2 is infinity. It does exist. It just goes to infinity. So you would only say it doesn't exist if it actually doesn't exist. Does that make sense? All good. All good. Okay. So 2 particles are moving on the x-axis. For 0 is less than 8, less than 2, we have this particle. And the velocity of particle Q, so different particle, is given by this. And we have some initial conditions. For 0 is less than t is less than 8, when is particle P moving to the left? All right, does everybody agree that for that question, particle P is moving to the left when its derivative is 0? Yes, no, maybe, kinda? All right, so VP. All right, I'm going to find the velocity of this. So what is the derivative of ln? So it's 1 over the argument. So t squared minus 2t plus 10 times the derivative of the argument, which is 2t minus 2. All right, so I get 2 times t minus 1 over t squared minus 2t plus 10. Okay, so, and then I want to know when is this thing equal to 0 so that I can figure out if, I can figure out what's going on. All right, so if I multiply through, I got t minus 1 is 0, so t is 1. That's my critical point. All right, and then what I like to do, I do a number line test personally. So if I was to plug in 0 into my derivative, what do I get? So I would get 0 minus 1, which is negative, and then I would get 10 on the bottom, so negative. All right, and then if I plug in a 2, I would get a positive. So, assuming that I start at 0, your particle is moving to the left from 0 is less than t is less than 1. And I'm not going to make the mistake that I just made, and I'm going to get rid of that. All right, does that make sense to everybody? All right, so this is a velocity of particle P. Everybody with me? Awesome, fantastic. All right, so for part B, find all times t when the particles are traveling in the same direction. Okay, so okay, so for particle P, we know that 0, all right, it's left and then right. So now we just need to figure out what Q is doing. So luckily they've given us the derivative already, so I can just set it equal to 0 and figure out what's going on. All right, and this is factorable, t minus 5, t minus 3. So when this is 0, t is equal to 3, t is equal to 5, and then I'm just going to do a number line test on this to figure out where it's positive and negative. So if I plug in a 1, I get negative and negative, overall positive. So this guy is moving to the right. All right, between 3 and 5, if I plug in 4, all right, it's overall negative. So that's moving to the left. And then if I plug in like a 6, this is overall positive. So this is going to be moving to the right. All right, so it looks like that the particles are going to move in the same direction from 1 to 3. So from 1 is less than t is less than 3, we can say that both particles are moving to the right. All right, and then similarly, all right, this particle is still moving to the right. Particle Q kind of went back and forth a little bit, but then from 5 is less than t is less than 8. Same thing. Both particles are moving to the right. Okay. Does anybody have any questions? Okay. Awesome. Part C. Find the acceleration of the particle at t equals 2. So acceleration, derivative of velocity. So I just have to take the derivative of this guy. So acceleration is 2t minus 8, just using the power rule. And then a of 2 is 2 times 2 minus 8, which is negative 4. All right, so now if we want to figure out if the speed is increasing, decreasing, or staying the same, we compare the acceleration and the velocity. All right, so we can say that if A is positive, just giving you a little background, if A is positive and V is positive, or if A is negative and V is negative, then it's speeding up. All right, if A is positive and V is negative, or if A is negative and V is positive, then you are slowing down. All right, so if acceleration and velocity are the same sign, you're speeding up. If they're opposite signs, you're slowing down. If your acceleration is 0, then you're staying the same. So our situation here is the acceleration is negative and the velocity is positive, so we are slowing down. So that is part C. All right, last part. All right, find the position of particle Q the first time it changes direction. All right, so does everybody remember that we had our critical points when t is 3 and t is 5? So it changes direction at t equals 3. All right, so the position. Okay, so here we're given an initial condition, which is super helpful. All right, so the position of Q at 3 is going to be the x at 0, which happens to be 5. And then we want to integrate from 0 to 3. Okay? And so I'll go ahead and change color and do that. All right, so to integrate, you raise a power, divide by your new power. All right, so this is 8t squared over 2 plus 15t. All right, if I simplify that, it's 1/3 t cubed minus 4t squared plus 15t, and then I want to evaluate between 0 and 3. All right, so I get 9 over 3 minus 4 times 9 plus 45. Okay, so 27. So 9 minus 36 plus 45. Okay. All right, so the value of that integral is 18. All right, so I get 5 plus 18 is 23. So this position is 23. All right, so by the way, for this one, this was a 3-point question. You got a point if you essentially set up the antiderivative. You got a point if you use the initial condition, and then you got a point if you got the answer. So even if you don't know how to get everything, make sure you write out your work, okay? That's going to be especially true this year. All right, make sure you write out the work. All right, so let's look at 6 here. Let f be the function defined by this thing. All right, g is a differentiable function. The table gives the values of g and g prime. And then here we have h, which is great. So for A, find the slope of the line tangent to the graph of f at x equals pi. These are my favorite types of questions. So the slope of the line tangent to the graph is the derivative. All right, so for part A, I'm going to just find f prime of x. And that is -2 sine of 2x. This 2 is coming from the chain rule. All right, plus e to the sine of x. So remember, e, the derivative of e to the anything is still e to the anything, but I've got to take into account the anything and use the chain rule. So the derivative of sine is cosine. Everybody okay with that derivative? And then we just plug in pi. So -2 sine of 2 pi plus e to the, let's see, e to the sine of pi times cosine of pi. All right, so sine of 2 pi is 0, so that guy goes away. Sine of pi is also 0, so this is e to the 0. Don't drop that out, it's not 0. And then cosine of pi is -1. Remember that this is 1. So the slope is -1. All right. Okay, let's see. So let k be the function defined by k of x is equal to this thing, and we want to find k prime of pi. All right, so let's go ahead and use our chain rule. So k prime of x is equal to h prime of f of x times f prime of x. Is everybody okay with that? And then we're going to go ahead and just plug in that pi. So h prime of f of pi times f prime of pi. Okay, so let's figure out what f of pi is. Oh, that's kind of helpful. We already found what f prime of pi is. It's -1. All right, so f of pi is cosine of 2 pi plus e to the sine of pi. All right then. So let's see. So what is cosine of 2 pi? Okay. All right, we should be getting 2. Yeah, cosine of 2 pi is 1. So 1 plus 1 is 2. All right, so this should be h prime of 2 and then times the -1. So now we have to actually find h prime of 2. All right, so here's h, and then we need the slope of this line, which looks like it's -1/3 to me. All right, so this is -1/3 times -1. We got 1/3. All right, so a lot of chain rule there. Man, they are all about this chain rule today. All right, any questions on that one? Okay, let m be the function defined by this thing, and we want to find m prime of 2. So we're going to have to use the product rule here and the chain rule. All right, so I'll rewrite m of x. Okay, and we have to use the chain rule and product rule. Okay, so m prime of x, so first derivative of the second plus second, and then derivative of the first. Okay, so remember g prime of -2x times -2. Can't forget the derivative of the inside. All right, and so let's go through and figure out what m prime of 2 is. All right, I'm just going to plug the 2 in and then we'll use the table. So g of -4 times h prime of 2. All right, we already figured that one out. And then h of 2 times g prime of -4 times -2. All right, so now we can read off on the table. So g of -4 is 5. H prime of 2 we already figured out is -1/3. H of 2 is, let's see, everybody like -2/3-ish? Okay, g prime of -4 is -1. And then this is -2. All right. So -5/3. That's a lot of negatives. Is it possible? Positive 1/3 for h prime of 2. It's a negative slope. This is h, so it's negative. The positive 1/3 was the k prime of pi. So here and here. Okay. Yeah, no worries, no worries. There's a lot of numbers flying around here. Okay, so this is going to be overall negative 4/3. I feel like I have a sign mistake somewhere. But maybe not. -9/3 is -3. No, we got it right. That's good. All right. So a lot of chain rule, a lot of product rule. And now D is kind of a layup if you know your theorems. Okay, so is there a number C in the closed interval between -5 and -3 such that G prime of C is equal to -4? Okay, does everybody agree that since I have derivatives here, G is differentiable? Therefore, G is continuous. That's a theorem on the interval, right? And so I can go ahead and then use the mean value theorem, all right? So now in order to do that, I have to set up G of -3 minus G of -5 over -3 minus -5. All right, and then we want to set that equal to G prime of C. All right, that's the mean value theorem. All right, so I can go ahead and read off those numbers. All right, it is 2 minus 10 over 2, which happens to be equal to -4. So therefore, by the mean value theorem, the conclusion is really specific. You want to word it precisely. All right, so by the mean value theorem, there is at least one value, C, and then you want to specify the open interval, okay, such that G prime of C is equal to -4. All right, if this was not continuous or not differentiable on the closed interval, we wouldn't get to make that conclusion. All right. Does anybody have any questions on that question? Okay. Hold on. Let me answer the question. I'm going to record the question. Let's say that we didn't know what was going on with this graph, okay? But we knew that h of, let's see, that's -2 is 2. And then we know that h of 3 is -1, all right? And let's just say I don't know the rest of, this graph. I don't know what's going on in here. That's pretty much all I know. I just know this. All right. But maybe I'm told that h is continuous. All right. And so if I'm only given this information, all right, where this is positive and this is negative, I can say that there's at least one value in the open interval from -2 to 3 that the function is 0, right? Because we go from positive to negative. That's when you use the intermediate value theorem. All right, and you would just say, by the intermediate value theorem, since h is continuous, there must be at least one value between -2 and 3 such that, h is 0. All right, and you only get that with continuity, right? But remember, if you have differentiability, then it implies continuity.